Welcome back, students. So now we have understood the location of roots and the 3 steps that we have to follow to solve the questions. Now comes the most crucial part, that is the application. Let's begin. So here is the question number 1 for the location of roots application. Okay, so let's see. The question says if both roots of the equation x square minus 9x plus a equal to 0 are positive and one is greater than 3, other less than 3, find all possible values of a. And here what is a is this parameter. Okay, so let's see what steps we will be following and let's follow them and get the proper answer. So our first step was that we used to draw the rough figure. So we will draw the figure and then we will be talking about the discriminant d, then minus b upon 2a range, and finally f of k. What is k here? K is 3. So we will be talking about f of 3. Okay, so let's move to the drawing rough figure. Now here we can see that a, that is coefficient of x square, is positive. Okay, so coefficient of x square is greater than 0. So that implies that parabola mouth will be upwards. So parabola mouth upwards. Okay. Now because there are 2 roots, that means both roots automatically means that implies that discriminant d will be greater than 0. That means parabola will cut x-axis 2 times. So cut x-axis 2 times. Okay. One root is greater than 3 and other less than 3. That means 3 lies between the roots. Okay. So now I can draw my figure. How can I draw my figure? My figure will look like this. I will have three like this. Suppose one root is this, another root is this. So it will look like this. Okay. So what was our equation? Our equation was x square minus 9x plus a equal to 0. X square minus 9x plus a equal to 0. Now the first condition that we will be discussing is on a, on d. The discriminant d will be greater than 0. Okay. Second is minus b upon 2a. Can I talk about minus b upon 2a? No. Because 3 can be located anywhere. Okay. So point at which minimum value occurs can be less than 3 or greater than 3 also. So f of 3, f of 3 here is always negative. Okay. So now let me put these 2 conditions and get my final answer, that is possible values of a. Now discriminant d greater than 0 means b square minus 4ac. So 9 minus 9 whole square minus 4 into a into 1 greater than 0. So this gives me 81 minus 4a greater than 0 or 81 less than 4a. This implies a will be less than 81 by 4. Okay. F3 less than 0. So I'll put, instead of x, I'll put x equal to 3. So 3 square minus 9 into 3 plus a less than 0. So 3 to the 9 minus 27 plus a less than 0 or a less than 18. Now I have to take intersection of these 2. Okay. So on a common number line, I will be plotting them and will be getting the final answer. So let me plot that. With the first, I have a less than 81 by 4. This is 81 by 4. This will be 18. So a is less than 18 by 4. Something like this. Okay. With the second, I have a less than 18. So a less than 18. So what will be final answer? A should be less than 18. Common intersection point, a should be less than 18. Okay. So whenever a is less than 18, it will always happen that I will have 2 roots and one root will be less than 3, another root will be greater than 3. Okay. So let's move to the next question. So let's see what next question says. If alpha and beta are the roots of the equation 4x square minus 16x plus a equal to 0, where a is real, such that one root alpha is lying between 1 and 2, second root of beta is lying between 2 and 3, find the number of integral solutions on only integer values of a. Okay. So first of all, I'll draw my figure. we can see that coefficient of x square is positive and there are two roots. So a is greater than 0. Here a means coefficient of x square. Okay. I always try to draw my figure. So this is effort that I am doing for figure. Okay. So coefficient of x square is positive. Discriminant d is also greater than 0. So graph will look like this. Some more information is given that one root is lying between 1 and 2. Let me use them. This is 1, this is 2 and this is 3. So alpha is lying here and beta is lying between 2 and 3. So graph will look like this. Okay. So let me put the condition. The first condition is discriminant greater than 0. Minus b upon 2a. Can I talk about minus b upon 2a? Anything that I can talk about minus b upon 2a? Okay, let's see. One root is lying between 1 and 2, another root is lying between 2 and 3. That is for sure that both roots alpha and beta are between 1 and 3. So I can put condition on minus b upon 2a only when I have something information about both roots. So both root alpha and beta are lying between 1 and 3. That means minus b upon 2a point at which minimum occurs, that will also lie between 1 and 3. Okay. But 2 can lie anywhere, so I cannot talk about minus b upon 2a in reference with 2. Third point. F of 1 is positive. Okay. F of 2 you can see that is negative. And f of 3 again is positive. So I will apply these conditions and get the final answer. Okay. So let me write them. 4x square minus 16x plus a equal to 0 is our equation. So first I'll put, let me first of all write all the conditions that we will be putting. Discriminant d is greater than 0. Then we will have minus b upon 2a lying between 1 and 3. Okay. Then f of 1 greater than 0, f of 2 less than 0 and f of 3 again greater than 0. Okay. Now discriminant d is greater than 0. So b square 16 whole square minus 16 whole square minus 4ac. So 4 into 4a greater than 0. So I have 16 minus a greater than 0 or a less than 16. Okay. Minus b upon 2a, so this becomes 16 upon 2 into 4 lying between 1 and 3. So that is automatically true. So that means in this case roots are always lying between 1 and 3. Minus b upon 2 is always lying between 1 and 3. Okay, now f1 is greater than 0. F of 1 greater than 0, I'll put 1 instead of x. So 4 minus 16 plus a greater than 0. So I have a greater than 4 minus 16 minus 12, a greater than 12. Okay. Now f2 less than 0. What it gives us? F2 less than 0, 2. So 4 into 4, that becomes 16 minus 16 2s are 32 plus a less than 0. So I have a less than 16. Okay. F3 greater than 0. So 4 into 3 square, 4 9s are 36 minus 16 into 3 48 plus a greater than 0. So this gives me a greater than 12 again. So we have, if I take the intersection of these three, you can easily see that a is always lying between 12 and 16. So I can have values from 13, 14, 15. So I have three integral values 13, 14 and 15. Okay. So students, I hope now you got an idea about the variety of questions that you can get from location of roots. Have you ever thought what happens when we have two equations and either one root is common or both roots are common? For this, just stay tuned with me. Have a nice day. Thank you.